Hi there, Mr. Sutton bringing you the IM3 7/8 Extra Practice Number 2 solutions on degrees, radians, and reference angles. For this problem, I'm trying to convert this into degrees because it's already in radians, which I know because I don't see a degree symbol. So to do this, I have to multiply by 180 over pi. Pi's are going to cancel, and to do this without a calculator, I can reduce the 180 and the 3, so that gives me a 60 in the numerator. 5 times 60 gives me 300 degrees. For this one, I'm trying to convert 135 degrees into radians, so I will multiply it by pi over 180, and then I have to reduce 135 and 180. Now, it helps if you recognize that 135 is a multiple of 45, and so is 180. So if I reduce these by 45, this is going to be, 3 pi over 180 divided by 45 is going to be 4. For this problem, trying to convert 345 degrees into radians, so I'll multiply it by pi over 180. Now, these are both actually reducible by 15. 180 over 15 is going to give us, that's 12. And how many times does 15 go into 345? Well, 15 goes into 360 24 times. So this must be 23 then. So we have 23 pi over 12. For this problem, I'm trying to convert this angle into radians, so I have to multiply by pi over 180, and I have to reduce 470 over 180, so I can definitely reduce those by tens, so that's 47 over 18, and 47 is actually a prime number, so we can't reduce this anymore. So then this is just going to end up being negative 47 pi over 18. For this one, trying to convert this angle into degrees. To do that, I will multiply it by 180 over pi. Pi's cancel. And now I can do 180 divided by 6, which leaves me with a 30 in the numerator. So negative 5 times 30 is going to give me negative 150 degrees. For this one, I want to convert this crazy-looking angle into something with degrees. So I'll multiply this by 180 over pi. Pi's cancel, that's the easy part there. And then I do know my factors of 180. I happen to know that 5 times 36 is 180. So I can reduce the 180 and the 36 to give me a 5 in the numerator. And now I just have to do negative 115 times 5. Well, let me see here. 5 times 100 is 500. 5 times 15 is 75. So this is going to be negative 575 degrees. To convert this angle from radians into degrees, I need to multiply it by 180 over pi. So we have pi's canceling. 180 and 6 can also cancel to leave us with 30 in the numerator. So now I just need negative 17 times 30. Well, let me think. 3 times 17 is 51, so this is going to be negative 510 degrees. For this problem, trying to convert 570 degrees into radians, so I'll multiply by pi over 180. And now reducing 570 and 180, well, I can definitely reduce those by zeros, or by tens rather, so that's 57 over 18. And I can go a little bit further. They're both reducible by 3. 57 divided by 3, 60 divided by 3 is 20, so this would be 19. We have a pi up there. And then 18 divided by 3 gives me 6, so 19 pi over 6. On this one, I'm trying to convert an angle into degrees, so let me multiply by 180 over pi, and then these pi's cancel. We have 180 divided by 3, giving us 60 in the numerator. 16 times 60, well, let me think. 6 times 16 is 96. So this would be 960, and don't forget the negative out there. So we have a negative 960 degrees. For this one, trying to convert 5 pi over 4 radians into degrees. And I know it's not degrees already because there's no degree symbol. So let me multiply by 180 over pi. Pi's are going to cancel. And I know that 180 divided by 4 is 45. So we have 5 times 45, which gives me, 4 times 45 is 180, so another 45 added to that is 225 degrees. On this problem, I'm trying to convert 390 degrees into radians, so I multiply by pi over 180, and I have to reduce those now. Now, I believe these are both reducible by 30 degrees. So that would give me, let's see here, 13 pi in the numerator and 6 in the denominator. For this one, I'm trying to get a reference angle for negative 300 degrees. So let me start by adding 360. I like to work with positive angles when I'm dealing with reference angles, just so I can figure out where I am on the unit circle. So adding 360 to that, that's going to be positive 60 degrees. And now to get a reference angle, I'm just asking how far is 60 degrees from the closest x-axis angle. Well, the closest x-axis angle is actually 0. 60 is 60 degrees from 0, so this is actually the reference angle, and this one's done. To get a reference angle out of this one, let's start by converting it into degrees. We're going to have to do that eventually anyway. So multiplying by 180 over pi, 180 divided by 3 is 60, and 60 times this 10 here gives me 600 degrees. Great. But I have no idea where that actually is on the unit circle or which x-axis side this is closer to. So I'm going to subtract 360 to get an angle that's in the same place, but it's at least between 0 and 360. So 600 minus 360, that's going to give me 240 degrees. And now I'm just figuring out how far 240 is from the closest x-axis angle. So it's closer to the 180 side, I believe. So to get the distance between this and 180, we have to subtract 180, 240 minus 180, and that's going to give us 60 degrees. For this one, I'm trying to get a reference angle for this one. So I'm going to first turn it into degrees by multiplying by 180 over pi. 180 divided by 6 is 30. 30 times 17, that's going to be 510 degrees, if I'm correct, and that's a negative. So now, in order to get something that makes sense out of this, I'm going to start adding 360s until I get a number between 0 and 360. So we have negative 510, and I'm going to add 720, actually. I know I'm going to have to add 360 twice in order to get that to be positive. So that ends up being, let me think here, 210 degrees. Now I'm trying to figure out how far 210 is from the closest x-axis angle. The closest angle on the x-axis is 180. So 210, I'm going to have to subtract 180 to get the distance to 180, positive distance. So 210 minus 180 ends up giving me 30 degrees. For this problem, trying to figure out the reference angle for negative 410 degrees. Now there's a long and a short way to do this. The long way to do this is to keep adding 360 until you have a positive angle, and then do some more subtraction until you get your reference angle. Here's a slightly faster way. So I'm definitely going to add 360 at least once. I want to at least get closer to a number between 0 and 360 before I try to figure out where I am with respect to the x-axis. So negative 410 plus 360 is going to give me negative 50 degrees. And now here's a little bit of a shortcut. I mean, I could add 360 and then subtract this from 360, but let's think about this now. The reference angle is just asking how far is this from the closest x-axis angle. Well, this is closest to the x-axis angle 0 degrees. How far is negative 50 from 0? Oh, it's 50 degrees from 0. So the reference angle on this is just going to be 50 degrees. For this one, I'm trying to figure out the reference angle for 300. So I'm asking how far is 300 from the closest x-axis angle. Closest x-axis angle is going to be 360. This is definitely closer to 360 than to 180. To find out how far this is in terms of angles from 360, I have to subtract, and so that I get a positive number, I'm going to do 360 minus 300, which gives me 60 degrees. To get the reference angle for this one in degrees, let's first turn it into something in degrees. I'll need to anyway, right? So let me multiply by 180 over pi. 180 divided by 6 gives me 30. So this is just negative 30 degrees then. And this is one where you could go a long way or a short way for finding the reference angle. Keep in mind, the reference angle is just asking how far is this thing from the closest x-axis angle. What is the closest x-axis angle to negative 30? Well, it's the angle 0 on the right side of the unit circle. How far is negative 30 from 0? Oh, it's 30 degrees. So 30 then is just going to be our reference angle. And you can do this with any angle that's in the fourth quadrant between 0 and negative 90 degrees. Alternatively, you could have added 360 to this. That would have given you 330. And then 360 minus 330 also gives you 30. On this one, I want the reference angle in degrees. Let me first convert this thing to an angle in degrees, and then we'll figure out reference angles. So I'm going to have to multiply by 180 over pi. Now this one's a little trickier. 180 divided by 12. I know my factors of 180, so I happen to know that's 15. But what's negative 25 times 15? Well, 10 times 25 would be 250. 5 times 25 would be 125. 250 plus 125 is 375, and that's negative. So that's how I did it mentally. You could have just done 15 times 25 long multiplication, and that would eventually get you there. So anyway, what's the reference angle for negative 375 degrees? I don't know, but I know that I can get closer to an answer if I add 360 and at least get this a little bit closer to an angle between 0 and 360. So if I add 360 to that, that's going to be negative 15 degrees. Now the long way of doing this would be to add 360 again, get some quadrant in the fourth, or some angle in the fourth quadrant, and subtract it from 360. A shortcut for this one, though, is just thinking to yourself, well, how far is negative 15 degrees from the closest x-axis angle? Because that's really all a reference angle is asking. Well, the closest x-axis angle to negative 15 degrees is 0 degrees. How far is negative 15 from 0? Oh, it's 15 degrees. So 15, then, is our reference angle. On this one, I want the reference angle for 690. To figure this out, let me actually subtract 360 from this so that I can figure out where I am on the unit circle. Otherwise, I have no clue where 690 is. So this is going to give me 330 degrees. Okay, well, I know where that is. That's in the fourth quadrant, and that is closer to the 360 side of the x-axis. So to get my reference angle, I just have to figure out how far this is from 360, which is going to be 360 minus 330. And that's going to be 30 degrees. For this one, I want to figure out the reference angle for 120. So I need to ask, how close is this to the closest x-axis angle? The closest angle on the x-axis is 180. How far is this from 180? Well, I could figure that out if I did 180 minus 120. That would give me a positive answer at least. So that would be 60 degrees.